So in the last session, we looked at root cause investigation in terms of tools to hopefully help you understand the causes of quality issues or issues you've got with your QMS. This session is more going to be about what are you going to do about it? What are you going to implement? What actions are you going to implement to actually prevent the reoccurrence of those quality issues or even prevent the issue from happening in the first place? So collectively, they're called corrective and preventive action, or CAPA. So the next couple of slides, we're just going to start with exploring what do we mean by CAPA. So what is the CAPA system for? So the answer to that, at the very highest level, there's just really an expectation that if you're an organization that's got a quality system, that you improve. So if you've got quality issues and defects, there is a mechanism and a system to prevent them reoccurring. So basically, in the case of the US regulations in terms of quality management, there's an expectation that organizations establish and maintain procedures for implementing corrective and preventive action. So basically, there's an expectation within the regulations that you improve, you identify problems, you implement fixes, and those fixes are verified. Now, CAPA, in terms of the FDA, is an area they always look at. It's a subsystem they always examine. It's an area for rich pickings for the FDA in terms of audit observations. Almost half of all actions that the FDA identify and cite organizations against are some way related to the CAPA procedure or process in terms of its inability to actually prevent reoccurrence of quality issues or even the absence of a CAPA procedure at all. So really, it's an area that all organizations need to sort of focus on in terms of quality management because it's always a focus of attention for the FDA. So this slide really covers some of the verbatim text from the Part A20 in terms of quality system regulations and CAPA. So there's an expectation that each manufacturer shall establish and maintain procedures for implementing corrective and preventive action. And there's a number of sub-clauses. So basically, you've got to have a CAPA procedure and system, and then there are various attributes that your CAPA procedure will be scored against in order to the FDA to decide whether your CAPA procedure is actually adequate enough and meets the requirements of their quality system regulations. Similarly, there are standards around quality management. So, for example, 13485 in terms of medical devices, there's a section on CAPA in terms of splitting it into corrective action and preventive action. And again, there's a number of clauses in terms of you have to demonstrate that your CAPA system not only is established, but it has attributes that satisfy the requirements of this quality system standard. So in the next couple of slides, we're going to cover some of the sort of, key concepts around CAPA in terms of corrective action, correction, preventive action, and what they mean. And one example we're going to use to help explain that is an example you've probably all encountered in terms of a flat tire of your bicycle. So basically, your tire's got a puncture, it's got a flat. In terms of what does CAPA mean in terms of addressing this quality issue? So in terms of correction, now correction is no more than just fixing the issue. You repair your puncture, you bring it back into its non-conforming state, and you repair the puncture. So basically, you seal the inner tube, you bring it back to its state of non-conformance, and basically you can ride on it again. So you don't prevent the issue happening again going forward. You just correct the issue you've got now. So it's all around fixing the issue at hand. It's rather than preventing it happening again in the future. Now, corrective action is about preventing it happening in the future. So in this example of a flat tire, one of the causes could be that the wall of the tire, the tread of the tire has become worn and then it's more prone to being punctured. So the corrective action here is to actually replace the tire before it becomes so thin that you get a puncture. So basically, this corrective action actually prevents the issue from reoccurring in the future because you basically you make sure that your tire is replaced before it becomes too thin. So you have a puncture, you understand what's caused it, and then you implement some action, in this case a corrective action, to prevent it happening going forward. Now, very similarly is the preventive action, and this differs from corrective action in that you've never had the puncture in the first place, but you can understand that if the wall of your tires did become so thin, they could become punctured, and you could have an issue going forward. So you instigate a replacement process for your tyre going forward, to prevent the issue from happening in the first place. So in this example, it's unlike the previous example. You've never had a punctured tyre, but the action is very similar in terms of you replace the tyre to prevent the issue happening in the future. And this is termed a preventive action because you've actually never had the original non-conformity, but you understand the situation well enough to actually implement some sort of action to prevent it potentially happening in the future. Now, in terms of CAPA, where it sits within the quality system, it really is central. It touches virtually every other one of the subsystems. Because of that, it is an area that the FDA always look at. And they also look at it because it actually gives you a window into your quality system. By peering into the CAPA system, they can get a really good feeling of whether the rest of your quality system is running effectively and efficiently. And really, that's one of the reasons they always look at this module. So really, as I said, this is an area they look at, and it's an area you really need to focus in terms of have you got the right procedure in place, and is that system working adequately? So what are the inputs to the CAPA system? Now, very often when people look at CAPA, they talk about CAPAs originating from non-conformances, and generally most organizations, when you ask them to produce a list of their CAPA events, that virtually all of them will be generated by non-conformances and maybe audit deficiencies. But this slide really needs sort of explains that you need to look a bit broader in terms of looking at the CAPA procedure and CAPA inputs in terms of there are other things other than non-conformances, other than audits you need to consider. So there are things like test data, how the product performs, equipment data, the amount of scrap, the amount of rework you do, how much product's returned, your process control data within your plant, your acceptance activities for suppliers coming in. So there's a whole body of information that should feed into and inputs into the CAPA process that go beyond just non-conformances and audit observations. So that sort of collection of input data is restricted to obviously the plant, and it's an internal data within your organization. But there's an analogous other subset of data which is external inputs in terms of inputs from the field, in terms of complaints, service data, reports, legal claims, warranty claims, obviously external audits, a subsection of complaints in terms of those you need to report to regulatory bodies. So you've got two really quite extensive pots of data that should feed into your CAPA procedure and your CAPA system. And really, you need to make sure you're thinking holistically about your CAPA system. And it's not just about addressing non-conformities. You need to think more broadly in terms of what are all of the data sets in terms of your ability of your QMS to function that should feed into your CAPA procedure to get a more sort of rounded and a more balanced and a more effective CAPA system. And related to that, really, the CAPA system is really, at its very core, is a business improvement process. So if the standards hadn't been written and the regulations hadn't been written, I'm sure all good, effective organisations would have a CAPA system. We just wouldn't necessarily call it that, because every good, organisation that wants to move forward needs to have ways to actually improve and identify problems and quality issues and prevent them from happening again. So really, the CAPA system really is a business improvement process and goes way beyond just a compliance requirement. You're going to have it for compliance reasons, but you do need it as well for genuine reasons to improve your business. And the reason for that, it touches lots of parts of your business, not just manufacturing, marketing, customer satisfaction, your personnel development, and really it really is linked to the overall success of your business. So it goes beyond just a quality system, sort of a tool, and really does span the whole organization. So in the last couple of slides, we looked about the inputs to the CAPA procedure and the process in terms of the external and internal sources. That then feeds into the CAPA procedure, and the CAPA procedure usually has sort of distinct elements. At the beginning, it has an element around data analysis and investigation. So in previous modules, we talked about quality data and quality planning and quality objectives. In the last module, we talked about root cause investigation to get into the root cause of issues. So this then leads into sort of the meat of this section in terms of what are you going to do about it? What are your implementation actions? How are you going to plan them? How are you going to implement them? And also, how are you going to measure whether they're effective or not? So that then leads on to the outputs of the capital procedure, which obviously is the implementation of change and changing documentation. But it also leads to, how are you going to tell the broader organisation about these improvements? Are you going to disseminate that information? Is management and review aware in terms of the outputs of the capital procedure? So really, in terms of the capital procedure and process, it has clear inputs and clear outputs. And those outputs are not just making the change; it's more broad than that in terms of making the organisation aware of the change and what's happened in terms of the changes you've made. So at the very high level, the broad phases of a Kappa system are initiation, which is basically you start. Then there's the planning phase. What are you going to do? What exactly are you going to do? Implementation in terms of what you're going to implement. The next stage is, once you've implemented these actions, have they been effective? Is there an effectivity check in terms of have those actions been? Did they meet your expectations in terms of implementation? Did they do what you expected of them? Did they prevent the reoccurrence of the issue or the occurrence of the issue going forward? Now, in terms of planning your Kappa, there's obviously a whole range of things you can do based on the root cause investigation, and a lot of these they're not all equally weighted. Some certain things you can do will completely remove the potential for that issue ever to happen again, and the other end of the spectrum, you can just basically reduce the impact of that issue happening again. So, in this slide, really, as you go from left to right, there are various buckets of Kappa actions in terms of they reducing their effectiveness in terms of preventing the issue from happening again. They go from removal to replace to refine to recognize to reduce impact. In the subsequent slides, I'll go through in terms of what I mean by each of these 5 R's. But in general, how powerful your Kappa is really should be proportionate to the risk of your issue. So, for example, critical non-conformities and recalls, you really need to be focused on Kappa that will eliminate or significantly reduce the chances of that issue from happening again. Whilst if an issue is of lower risk, you can maybe get away with just reducing its impact or other detection systems. And I'll expand on that in the next couple of slides. So the sources of Kappa for corrective action, obviously there's non-conformances and audit deficiencies, but there may be Kappa coming from suppliers, customer complaints, outputs and management review, or you can generate a Kappa as a standalone event. There's no reason why it has to have a parent. Related to that are Kappa events where there's no quality issue or event within the system. So there's no non-conformity that's happened to trigger you to do something, but you can tell from trend reviews or scrap reviews or yield reviews or process control data, or you've looked at specifications or management review have looked at data sets, or you've looked at more broad product reviews or internal performance reviews and decided you haven't got an issue now, but you could potentially in the future have an issue going forward. So basically, it's a very preventive action in terms of you're not reacting to something that's happened in terms of a quality event. You're sort of predicting it may happen in the future and obviously implementing an issue before it actually happens at all. Now, in terms of Kappa, in terms of if it looks like Kappa, walks like Kappa, talks like Kappa, it really needs to go in your Kappa system. Even though some of the activities you implement will actually can be placed in the non-conformance process or the audit module, then really it needs to go into the Kappa procedure in order that it's recognised by the FDA you are appropriately using the Kappa procedure and process going forward. Even though, as I said, you may be controlling aspects of its implementation within other subsystems such as change control and non-conformance, there is an expectation that you do use your Kappa system appropriately. And also the flip side of this is also you want to get credit for the good things you do in terms of preventing quality issues going forward. Then you really want sort of the credit and then the kudos for the good stuff you're doing. And if that is sort of spread across different subsystems of the quality system and not in the CAPA procedure and in the CAPA database, then you won't necessarily get credit for it in terms of recognition doing an audit or an inspection. Now, the next couple of slides really will just walk through the different power levels of CAPA in terms of their power to eliminate the original issue from happening again or happening at all. Obviously, on the left-hand side, we talk about the most powerful is removal. Here, you actually prevent any possibility of that error happening again. So in this example, you've got potentially transcription errors between the balance and the paper documentation. And if you link a digital printer to the balance and eliminate any potential for transcription, then that quality event can't happen again because there's no transcription occurring at all. So that's a form of removal CAPA. Other ways around removal CAPA, the types of removal CAPA are where you error proof. So in the right hand side of the slide, there's two different ways you can connect to two cables, but if they're of different sizes, there's only one way you can only do it right in terms of error proofing. You basically removed any potential for that defect to happen. And obviously, this is the best port of call for CAPA. You've removed any potential going forward for any repeat events. You can't always do that, and very often you just need to modify the process you've got in terms of altering it to make it more reliable by design. And very often this means making it simpler and less complicated. So that's your next port of call in terms of your CAPA, in terms of replacing modifying your current process. So you're not eliminating all potential for it to happen again. You're just making it less likely. Related to that is the next level down, where basically you refine the process you've got, you're stuck with it, but basically you make it easier to perform. So in this example, attaching the drill bit to the mounting, you make it less likely you're going to do it wrong. So there's more visual instructions. There's 5S, there's color coding. So you're taking the procedure on the process you've got and making it more likely that procedure will actually be followed, and you won't generate any potential defect. Again, it's weaker and it's not like full replacement and eliminating the system, the potential for that error to occur. You're just reducing the likelihood for that to happen. The next level down is really basically you just accept that you're going to have a level of defects and you put in systems to detect them and remove them. So in the example on the left-hand side, you've got a conveyor with cameras looking on the line, and if it detects a defect, it will remove it. So basically, you're not improving quality necessarily. You're just removing the defects from the process. Or you might do that through a trend review and trend charts. So basically, if something goes out of specification, you can remove. Again, you're not engineering quality into the system. You're actually just removing defects from the system as the system operates. And obviously, that's much weaker, and that's probably not where you want to go in terms of improving quality. As opposed to actually removing those defects or preventing them from being created in the first place. And the lowest, the sort of weakest R is reduce impact. So basically you let the system run and you accept there's a level of defects and you sort them out and you rework at the very end. So you sort good from bad, and basically you don't remove it during the process. You just do a bit of sorting at the end, and obviously you just reduce the impact of the issue either on the customer by various means. So basically you reduce the impact of your quality issue on the end user. Now, related to that is a form of capital around training. Now, if the FDA, when they look at training, they take quite a dim view when you use training as any form of CAPA where it's a standalone. And really, training as a CAPA should only be used in conjunction with the other forms of CAPA I've described previously. And if you're looking at training as a CAPA, you really should be asking yourself whether the issue is actually the process rather than the individual. Is it an issue with the process or the documentation rather than human error, and really do you really think by retraining this is going to be an adequate prevention of the issue going forward. Now, this slide covers some of the common mistakes in planning for CAPA. Very often, you can be too narrow in your scope of the investigation, and you should ask yourself, okay, I'm looking at this one particular issue. Are there other processes, or similar products or equipment that are impacted, and I need to think a bit more broader, in more broadly in terms of my implementation of CAPA. Related to that is where the issue starts and stops. Are you looking with too narrow field of focus in terms of the issue? Do you need to look wider in terms of where the issue starts and stops? Another mistake within planning of CAPA is you don't have the right expertise in terms of a cross-functional team, and related to that is you may get to the incorrect or a very poor root cause. And obviously, if you get to the wrong root cause, and you will implement the wrong CAPA for the wrong problem. So basically, it's all around having the right people and the strength of your root cause investigation, as we covered in the last module. Another mistake within planning of CAPA, at the CAPA planning stage, you should be deciding and documenting how you will decide the effectiveness of your CAPA. How will you do that in terms of, is there real clarity in terms of how you will measure the effectivity of your CAPA actions? Now, in terms of due date, obviously you have to set a due date for the implementation of the CAPA. Excuse me. Now, that should be commensurate with the risk of the issue. So obviously you've got a high risk issue, high potential for patient impact. You really want to be piling resources and implementing those actions very, very swiftly. Not all things are like that. So basically, you could have a CAPA where it's a lower risk issue, and you can afford to actually have a due date that's longer. But really, you need to use some educated judgment in terms of how you set that due date, because not everything's critical in terms of CAPA, and you need to set those due dates appropriately. Related to that is you don't have to do everything at once. You don't have to have the full all singing or dancing CAPA in terms of prevention. You can do things in between, in terms of you can have more containment CAPA in terms of that's running in parallel as you work out how you're going to completely remove the issue. So you don't have to do just one thing. You can do multiple things running in parallel to reduce risk. So really, this is quite important when you get issues where we got quality events related to recalls. Very often you want to do the whole the ultimate CAPA and implement that, but very often it's better to contain the issue in the short term as you work around what is the best solution going forward for a more permanent and a better fix. It's quite key within the planning phase. You're going to have to decide how you're going to decide how effective your CAPA is going to be, in terms of how you're going to judge that, in terms of how you're going to judge that and assess that and document that. In terms of, it will have to be based on objective evidence. So you could ask yourself how it will come onto that. How will it be measured? Who will do it? Over what time frame? How are you going to sample? Are those samples going to be could be valid in terms of the statistical rationale? So basically, during the planning phase, you need to be very clear about how you're going to do that. So some common mistakes in the effectivity check is that you're not the effectiveness check is not specific to the root cause that you're trying to address, or the effective check is not has acceptance criteria that isn't measurable or well defined. So if it's a very vague effectivity check with no really clear criteria of how you're going to measure it, then that's obviously going to end in tears, and you're going to be unable to say whether your CAPA action has been effective or not. There's also an expectation during the implementation phase, which is the next phase in terms of when you actually implement any actions is that you don't cause another problem in terms of you're fixing one original problem by a kappa action, but you're not causing another issue in the system in terms of your actions don't detrimentally impact the quality of the products or your process, and you don't introduce new risks. So there is an expectation that you use the appropriate tools. So if you're making process changes, there's an expectation to use tools such as FMEA to understand whether you've caused any further process risk, and what are the mitigations being placed in order to contain that risk level. So this slide covers some of the common ways to measure the effectivity, which is the next stage of the kappa in terms of trend analysis, sampling, audit, periodic checks. Excuse me, and we'll come on to some of that in a bit more detail in this section. One broad concept is if you move the effectivity, the kappa effectivity upstream in the kappa plan, and I'll explain what I mean in the next slide, then that can only be a good thing, and I'll expand on that in a minute. So in terms of the requirements of kappa effectivity, just to summarize, you need to make sure that you try to determine whether your kappa meets the expectations of your kappa plan. And this may or may not be complete elimination of the original issue. So it might be appropriate where you reduce the risk. But unless you're clear about how much it will be reduced, it will be very difficult to verify whether your kappa is actually effective or not. And a kappa could be very effective if it reduces the risk to a pre-described level, but doesn't eliminate it completely. You can decide that is, by its definition, an effective kappa. So you need to sort of articulate how much risk reduction is good enough for you in terms of saying your kappa has been effective or not. Again, make sure that when you look at the kappa effectivity, you didn't expect to cause any problems in terms of implementation, in terms of causing new unforeseen failure modes. But did that actually happen when you implemented the kappa? Did nothing change? You didn't cause any further problems. And really, there should be rational for the effectivity plan. Is really dependent on the type of kappa that you will implement. Obviously, that you're actually going to have to use data in terms of measuring the effectivity of the kappa, and really need to define what that's going to be up front. And actually, it's more important that it's better to actually have confidence before you implement the kappa, that you've got confidence that kappa will be effective. So really the verification stage and the effectivity check really in this whole process shouldn't be an experiment. There should be upfront data in terms of feasibility where you believe that the kappa will be effective prior to actually implementing the kappa. So the effectivity check shouldn't just be a blind check. You should have pretty good confidence that your kappa will be effective based on some data you've got up front. And obviously, you're going to have to base it on some form of data. So basically, some sort of very often some numerics data in terms of sampling, and ideally it should be statistically based. And really, in measuring the kappa effectivity, it's got to be reasonably and reasonably practical. So basically, if you've got a kappa effectivity check that says you're going to check the next 10 batches, but you only get one batch every 2 years, then obviously that's not reasonably practical. Or it's going to take thousands and thousands of man hours to measure the effectivity of the kappa, then obviously that's not reasonably practical as well. So in the effectivity plan, which is created during the planning phase, you really need to nail down who will perform this assessment. Is it quality? Is it operations? Is it both? How is it going to be measured? How is it going to be documented? When will it be measured? When will it have to be done? What's the acceptance criteria? And also some rationale of why the acceptance criteria is that it is defined in your plan. What are the reasons behind that? And if it's statistically based, how are those numbers derived, and what's the sort of rationale? And also, what the course of action are going to be? Are you going to carry out if you find that your kappa isn't effective? What's the acceptance criteria? And also what are the consequences if you find your kappa isn't actually effective? So in terms of Kappa effectivity, that will really depend on what the type of Kappa you've implemented. If you've done a removal Kappa, if the risk is completely eliminated in a change in a process, then sampling afterwards hasn't got a lot of logic. If you can rationalize it can't happen again because this step simply isn't in the process, then checking afterwards it doesn't happen has no logic. So really, verifying the effectivity of a change that's been completely removed, it's more appropriate to actually reference, did you remove that step? Have you got change control documents that demonstrate that step has been eliminated? So there's no rationale in checking afterwards that you eliminated eliminated that process, and then there's been no manifestations of the quality issue going forward. That doesn't make any sense. It's more around, have you eliminated that risk, and can you demonstrate that with documentation? Um, Related to that, you may still need to do a degree of monitoring to check you haven't caused any other failure modes from happening, but that really occurs. That really relates to all of the types of Kappa, in terms of some degree of monitoring to check you haven't broken something by implementing your Kappa action. So replacement again is more around, you know, replacing your process with something that's more reliable by design. So basically, documents you could use to measure the effectivity of the Kappa could be capability studies of the new process, validation reports of the new process. You will generally need these to implement your Kappa. So basically, you shouldn't implement the Kappa and do those after the event. These should be upfront documents you should have available to demonstrate that, yes, I've changed the process and I believe it to be more capable because I've performed this capability study, or I've performed this validation. And also, you need to base your judgment on some sound rationale and statistics. So consider sort of proportion tests to demonstrate the process is different statistically before and after you've actually made your change. The next stage Kappa is refine, where basically you basically you basically facilitate the change. You basically make a change in the process whereby it's easier to actually execute, and it won't be necessary to sample afterwards that your expectations have been met and the new process is more reliable, and you need to set criteria in your Kappa effectivity plan to demonstrate what's your acceptance criteria in terms of reliability. And again, you should use the appropriate statistics to support your rationale. Um, the next level is around, you basically, detection in around recognizing the defect. So you're allowing the process to run, but basically you're picking good from bad, and basically you're recognizing the defect. So it's a very weak form of Kappa. But in terms of the ability to detect, yeah, and measure ways of measuring effectivity of that Kappa, you should have documents that sort of are capability studies, gauge R&R studies, to demonstrate the effectiveness of your new detection system in order to contain the defect. And again, you basically may need to monitor the system for a period of time to demonstrate your defects have been contained and ongoing. And they meet your expectations in terms of the number of defects are getting through your gate, if you've implemented a gate to contain defects, as opposed to eliminating them in the first place. So the last, in terms of reducing the impact of defects around, sort of basically mitigating the impact of the defects around sorting and removing, again, there are similar studies you need to show that if you are going to sort good from bad at the end, and that's your port of call in terms of your Kappa, those systems are reliable in terms of repeatability and reproducibility studies to demonstrate that they're actually effective as a detection system in terms of sorting good from bad. And again, you may have to monitor for a period to show that they are robust and you're actually containing those defects appropriately. In terms of sampling, very often in effectivity checks, you want to sample some batches. Um, Again, the sampling, it should be reasonably practical. Again, if lots are occurring at a low frequency, very often it's not possible to sample all the lots you want, and you really should set, a criteria that's reasonable in terms of being able to do that activity within sort of a time frame between 0 and 6 months. You don't want kappa samplings and effectivity checks to go on for years and years and years, because obviously that leaves the kappa event open until you can close that loop and demonstrate that the kappa has actually been effective. There are other forms of non-statistical sampling. You trend data, just look at whether it's stable. Is it moving in the right direction? You could do periodic checks and audits. So there are other ways you can look at the data sets to measure the effectiveness of your kappa event. Now, sometimes in life we don't get what we want. So sometimes we implement kappa and you think it's going to be this good and it isn't. Now, there should be some clearly defined expectations within your kappa plan. Is what are you going to do if you don't have a kappa that's actually as effective as you would like? And one of the deficiencies in many kappa modules is it lives in a binary world. It's ineffective, it's effective, or it's not effective. But actually, in the real world, sometimes it can land in between. So you may not have reduced the risk as well as you wanted to, but it still would have reduced the risk quite significantly. But it may not go as far as you actually hoped or expected. So what it's really in the kappa plan, you really got to document what you're going to do then. What's the case of, are you going to say the kappa is ineffective and basically start again and look at further actions to reduce risk? Or are you going to make a risk-based decision that actually you're going to live with that level of risk, even though you have not potentially gone as far as you wanted? So basically, you need to decide within your system which direction you're going to go. So basically, it's easier to actually document that up front than it is to actually react it at the end. Because if you react it towards the end in terms of your effectivity check and you don't get what you want, and then say, actually, well, it's good enough, and then there's an element of moving the goalposts. But if you're clear up front and saying if it's not as effective as I want, I will judge on a case by case basis based on amount of risk it has reduced and make a judgment. Then that's a bit better. So in the five kappa types and the five R's, on the left hand side you've got the different sorts of kappa, and on the right hand side you've got the sort of documents you could reference as an effectivity check. So removal, you've got again, have you removed the potential for that? Have you changed the process? Has it really been changed? So things such as change orders, replacement. You basically modified the process. Uh, Documents you can reference are validation studies, training assessments, capability studies. If you're just refining the process in terms of your ability to execute it better, capability studies and sampling. And likewise, if you're going to contain defects, what's your gating system? How powerful is it? Is it reproducible and repeatable in terms of gauge R&R studies and general process monitoring? So there are documents that are within your QMS that you should be able to point to as part of your effectivity checks, and they are valid documents, and you really should be considering them not at the very end of the state, in the end of the kappa sort of planning cycle. You should be considering them more upfront in terms of when you actually write the kappa plan and decide what you're going to do. And the final slide really is that you've got this whole process flow going from issue and implementation and effectivity check. There really should be a board that looks holistically at the kappa process, and very, very often organizations have what is known as a kappa management board or a quality board, and very often they have a very specific kappa board. And really that board has real power in terms of its ability to look at the kappa system. And I do encourage you to set up a board with representatives, not just from quality, but from across quality and production and technical areas if needed, and research. And really, if you've got a board in place, then they're very powerful. And one of the things that they should be responsible for is monitoring the status of all kappa records and your metrics in terms of cycle time, they're the custodians of the Kappa process, and they should be the guys you should have to argue the case in terms of you need Kappa due date extensions. They should holistically look at the Kappa process and understand, what are the items that are preventing your Kappas being more effective or efficient execution of the Kappa process. And they should really be looking at all of the inputs and the outputs of the Kappa process we described previously, in terms of making sure the Kappa system is more holistic and it touches all of the parts of the QMS it needs to. And really also communicating the output of the Kappa process in terms of, whether it's effective and efficient. So it should feed into quality system management review to monitor the overall health of the Kappa procedure and the Kappa system. So that covers Kappa in terms of, this session. We've looked at ways of implementing Kappa and different types of Kappa and how to measure the effectiveness of Kappa. And that follows on from the previous module in terms of root cause investigation. And the next module, we'll look about more sort of generally in terms of how you manage your Kappa system and also how you manage your change control system. So it's all about more holistic change and how you manage that in terms of how you prioritize events. How do you decide, which events you're going to move forward? So I'll cover some tools and systems in the next module, and we'll also revisit the maturity model in terms of how you manage change in terms of those various levels of the maturity model and what they mean in terms of moving through that model in terms of improving your way of and your ability to manage change within your organization. So hopefully I'll see you then.